All right, so let's continue on. We're going to do the next couple practice problems together, and then you guys are going to practice all on your own. So, same thing first. Let's split up our compounds. Okay, that means H is going to go with OH, NO3 is going to go with barium. Find their charges, +1 for hydrogen, -1 for nitrate. Barium's a +2, hydroxide's a -1. So now I have those charges we saw from the last practice example where those charges are going to be needed, so it's good to just write them out right away. So now let's start working on our balanced equation. We got HNO3. Go and look at your solubility rules. Is that soluble or insoluble? Again, nitrate's one maybe you will end up memorizing. There are no exceptions. Anytime you see nitrate in a compound, it's always going to be aqueous. This is nitric acid, actually. All right, barium hydroxide. Again, I'm writing it exactly the same way. Subscripts have to be there. Checking my solubility rules. So I'm going to go look for hydroxide. It's normally insoluble except when it's combined with group 1. Calcium, barium is an exception, so that means it's going to be soluble as well. Typically, when you see your starting materials, guys, they're both going to be soluble for the most part when you do these. So now we're going to predict our product. So we said that barium and nitrate were going to pair up. When we do the crisscross method, you're going to get BaNO3 and we said before all nitrates are going to be aqueous. And then now here is the challenging one to kind of note. When you have HOH together, guys, what is HOH? We can write it like that because it helps to balance it, but really HOH is just H2O. Is H2O aqueous? That's the big question. Remember, what does aqueous mean? Aqueous means an aqueous solution. A solution is a mixture where you have something mixed with water. If I mix water with water, what do I have? It's water, right? So is it technically a mixture? The answer to that is no. So whether you write it as HOH, like I'm going to because it's going to help me balance, or if I write it as H2O, guys, that's a liquid. It's not an aqueous state of matter. Because, again, by definition, aqueous means it's a solution, which is a homogeneous mixture, which means I have to have a salt dissolved in some solvent, which is typically water. But if I mix water with water, it's just water. So it's a pure liquid. And that's big to note for when we do our net ionic equations. So let's go through and balance it. I've got 2 hydroxides on the left, so I need a 2 here, and then I need a 2 right there. On to our complete ionic equation. So if you think you're confident with it or want to try it, pause the videos now that we have it all balanced out. Go through the process. Split up your aqueous ones, cancel out your spectators, and try to get your net ionic, and then you can jump ahead or watch the video with it, or I'm going to work through it as well, so you can always watch that as well. So HNO3, that's going to be broken up. I've got 2 hydrogen ions, aqueous state of matter, plus 2 nitrate ions, aqueous state of matter. I can split barium hydroxide up because it's aqueous as well. Ba2 plus 2 hydroxide ions, aqueous state of matter. Can I split up barium nitrate? Yes, I can because it's aqueous as well. 2 plus aqueous plus 2 nitrate ions, aqueous. Now here's the question. Can I split water up? No, because it's a pure liquid. Okay, it's a pure substance. It's going to stay together. So I'm going to have 2 H2O liquid. Again, you can keep it as HOH if you want, but now that we've balanced it, I'm going to rewrite mine as H2O. It's the same thing, guys. Don't get confused with it. So now my next step is to cancel out my spectator ions. Those are the ions that stay the same. So do I see 2H plus aqueous on the right? I do not, so it's going to stay there. Do I see 2 NO3 minus aqueous on both sides? Yes, I do. Those are going to get canceled out because they're the same. They're watching. They're not participating. I've got Ba2 plus aqueous on the left, and I've got it on the right as well. So those are going to get canceled out. 2 OH minus aqueous, I do not have that ion, so now I'm going to drop everything else down. 2H plus aqueous plus 2 OH minus aqueous yields 2 H2O molecules. And notice, guys, by us balancing it, we know that our net ionic equation is going to be balanced in the end because we've already balanced it, and we've carried those coefficients all the way through, so we don't have to worry about going back and doing it again. So there's our net ionic equation for the reaction of nitric acid with barium hydroxide. I would encourage you guys to now, since you've seen 2 practice examples, to pause the video and to go through and try and work number 3 on your own, and then re-watch the video. So here we go. Let's go through this now. Again, I'm going to do the same process. Okay, split them up. This is a +1. This is a 2-. This is a 3+ for aluminum, and this is a -1 for nitrate. So I'm going to work on my balanced equation, K2S. When I go back and I look at my solubility rules, that is aqueous plus aluminum. Oh, there's a nitrate. I know that not all nitrates are aqueous, so I don't need to worry about flipping back to my table F. Then it doesn't matter, again, which order you put the products in, guys. They're both products, so you just need to have them both there. So let's say I'm going to put potassium nitrate here. I'm just going to do that. Plus aluminum sulfide. And when I look at that one, guys, that is going to be my solid. So the next step is I need to balance it. I should have a 3 here and a 2 right here, and then a 6 in front of the potassium nitrate. Now I can go through and start working on my complete ionic equation once that is all set up. Now, this is where things get a little bit challenging. Notice I've got a subscript 2 here plus a 3. So when I do 3 and distribute it out, 3 times 2 is really how many? It's 6. So K plus aqueous plus 3 sulfur 2- aqueous plus 2 aluminums, which is a 3+ charge, plus, again, here's that, 2 times 3 because it distributes out, 6 nitrates. All right, split this next one up as well, 6 potassiums. So if you guys got this one wrong, that could be why, because you forgot to distribute out that coefficient times or multiplies by the subscript. So that's just a little quick fix for you. Again, if you show as much work as possible on your quiz, I can give you partial credit. If this was a Regents style question, like if you saw this on a Regents exam, this would probably be like a 3-part problem where you're doing kind of each step within a problem. So you wouldn't just have to go through all this work and not get any credit potentially. It would probably be a multi-step problem. So don't stress yourselves about that. That's how the Regents, when they're longer ones, they like to break it up so you get partial credit within it. So now you're looking for your spectator ions. I'm going to cancel out potassium because it's the same on both sides, and I'm going to get rid of the nitrates as well. Then I'm going to drop everything else down. So I've got 3 sulfide ions plus 2 aluminum ions. Again, you've got to have their states of matter. You've got to have the charges. If you don't have all that, it is wrong. Okay, so if you try to cut corners just to get it done quicker, you're going to lose points and it's going to be wrong. But there's the process. So you've got plenty of practice problems here. I've got extra practice problems. You need to work out as many as you need to until you can do this process in your sleep, because you're not going to have the step-by-step notes on a quiz or anything. So you've got to know this process. So go step by step and really work to learn them, okay? So if you have questions, always ask, but you know that I'm going to be asking you questions as well, so make sure you know this process. Till next time, I'll see you later.